students. Welcome. All right. Today, Vani ma'am is back again. Your WOC is back again with assertion and reasoning questions. I'm going to explain every question of your P block and that too assertion and reasoning questions with detailed explanation. Until now, for P block, I have sent you the trends video, correct? I have sent you trends, handwritten notes, trends I have done already, right? On Sunday, this upcoming Sunday, we are going to do MCQs on P block, all right, at 8 p.m. in the evening. Okay, and after this, now I'm going to teach you assertion and reasoning questions. So let's start off. I'm going to do detailed explanation of everything. Please watch the video till the end. I'm going to complete group 15, group 16, group 17, and 18. Let's start off. All the best. WOC will never leave your hand. Remember, students. So, your world of chemistry, your Vani ma'am, ready with the first question. Let's see. So, first question. Nitrogen is unreactive at room temperature but becomes reactive at elevated temperatures or in the presence of a catalyst. In nitrogen molecule, there is an extensive delocalization of electrons. All right. Assertion is given, reason also is given. I have to select which option is right. Now, remember, students, first I'll give you the answer, then I'll explain it in detail. So, according to me, nitrogen is unreactive at room temperature. Yes, it is true. It is true. Where is that? A is true. Then, in nitrogen molecule, there is extensive delocalization of electrons. R is false. This is right. This is wrong. Let's explain it. Let's in detail see it. So first of all, students, nitrogen atom, when I see, just see this. Yes, nitrogen atom has a triple bond. Correct? Its bond dissociation enthalpy is 946 kilojoules per mole. I require 946 kilojoules per mole to break this bond. Very, very high. Correct, students? And important thing is the distance, the bond distance between them or the bond length is 109.8 picometer. So here what is happening? It's very, very strong. The bond is strong. It is triple bond. So you only tell me here bond dissociation energy is more, bond length is so much, it has a triple bond. That's why nitrogen is unreactive at room temperature. According to your assertion, nitrogen is unreactive. Yes, it is perfectly right. Why? Because it is all the parameters are more. Triple bond is very difficult to break. So assertion was right. Now they have given you one more thing. In the presence of a catalyst, it starts reacting. Yes, see this, students, see this diagram. So what happens is when you send your nitrogen gas, okay, you're creating low pressure inside this, and what you're doing, you're creating high tension, high electrical discharge, low pressure and high electrical discharge you're creating here. When you create high electrical discharge and low current, what happens, immediately the nitrogen gas starts dissociating. So what will it do? From this color, slowly the product, slowly glows into a brighter quantity. Brighter, it will become purple, then it becomes yellow. So at high temperatures, what happens, students? At high temperatures, automatically nitrogen starts reacting. Nitrogen starts reacting. So what did they give me? Assertion, they said, yes, it is right. And in the second case, they said reason, in nitrogen there is delocalization of electrons. Reason is wrong. Just see, students, why reason is wrong. In this case, nitrogen atom, it is triple bond, right? Triple bond. There is no delocalization. It is completely fixed. The electrons are tightly bound. So there is no delocalization. No delocalization. There is no movement of electrons. That's the reason. Reason is wrong, which they gave me. Correct? And they said there is delocalization. They said no, there is no delocalization of electrons before because of triple bond. Easy. So both the assertion and reason are explained clearly. Let's go to the next question. P4 is more reactive than nitrogen. Phosphorus single bond is much weaker than N triple bond N. All right. First of all, phosphorus is more reactive than nitrogen. Yes, it is right. Perfectly right. We are going to see the reason. And phosphorus single bond is much more weaker than compared to triple bond. This also is right. And see, students, both are talking about the bond strength only, correct? Because it is single bond, it is reacting more, it is more reactive. Nitrogen is triple bond, that's why this is less reactive. So the option is assertion is right, reason also is right, and reason also is a correct explanation of assertion. Let's see the explanation. First of all, P4 is more reactive than nitrogen. Why it is correct? See here. When I see the P4 molecule, what does it have? Yes, students, P4 molecule has angular strain. Yes, see here, this is there, this is there, this is there, this is there. So because of this, P4 molecule has angular strain. And because of this angular strain, what will happen? All are single bonds. All are single bonds. When all are single bonds, what will happen, students? Their bond length or the bond, this one is weak. Bond, okay, the bond, whatever is there, bond is weak. When the bond is weak, automatically more reactivity. Easy, more reactivity. That's why assertion was perfectly right. Then what did they give me? What did they give me? Here they said nitrogen. Nitrogen is basically PP single bond is weaker. So the reason assertion was right, more reactive because of this single bond, and reason also was right. But let us see in case of this one. In this case of nitrogen, it is less reactive. Yes, it is less reactive. Why? Because I said no. The bond distance between them is 1.09 angstroms. Very, very tightly packed. In case of nitrogen, it is triple bond. Correct? It is bond is strong. Bond is strong, and that's why it is less reactive. Okay? That's why both assertion are right. Reason also is right. Easy? Very good. Now let's see the next question, students. Easy? All right. So ozone is a powerful oxidizing agent in comparison to O2. Okay. Ozone is diamagnetic and O2 is paramagnetic. Yes, students, remember both assertion is right, reason also is right. We are going to explain that, but you only tell me this is talking about oxidizing property. This is talking about diamagnetic nature and paramagnetic. This is talking about unpaired electrons, and this is talking about paired electrons. Both are not related, isn't it? But assertion is right, reason is right, but reason is not the correct explanation. Option 2. Let's see the explanation. See, students, see here. First case is they said ozone is a powerful oxidizing agent. Why? Because it releases nascent oxygen. Because of this release of nascent oxygen, ozone is acting as a powerful oxidizing agent. That's the reason assertion is right. Then they said ozone is diamagnetic in nature. Check this reason, check reason, diamagnetic. See, they are paired. That's why reason also right. Then they said oxygen atom is paramagnetic. Yes, see here. In case of oxygen, they are unpaired electrons here. This one, this is unpaired. That's why it is paramagnetic. So reason assertion is right because they said it is powerful oxidizing agent because of nascent oxygen. Reason also is right because they said ozone is diamagnetic according to the structure. O2 is paramagnetic. Both are right. But reason is not explaining assertion. Both are different concepts. These two are different concepts. That's why. Next question. Fluorine has low reactivity and fluorine-fluorine bond has low bond dissociation enthalpy. Yes. First of all, fluorine has low reactivity. This is a wrong statement. We are going to prove why. Why? Then Fluorine has low bond dissociation enthalpy. This reason is right. Shall we prove this? Let's see. First of all, we will check fluorine has low reactivity, they said. Right. Now let's see. So observe carefully, students. Reactivity depends upon what? First of all, we said fluorine has low reactivity, right? We said it is wrong. Why? Just check. When I take fluorine atom, what is the speciality, students? It has high electronegativity. Okay. Done. Z effective or nuclear charge is maximum. Okay. When the nuclear charge is maximum, what will happen, students? It will pull pull electrons more from other thing, whichever is linked. Yes. When it pulls electrons more, what will happen? It will get negative charge. Correct? It will get negative charge. Now, tell me, students, when you see all these properties, is it not more reactive? Is it not more reactive? Yes, because Z effective is more. Whichever it is combining, it tries to pull the electron density. So what did they say? Fluorine has low electronegativity. They said that's wrong. Fluorine has more reactivity because Z effective is more. That's why we said assertion is wrong. Now they said fluorine bond dissociation enthalpy is low, they said. See here, students. So assertion, we have proved it. Now when I take the reason, see here, fluorine bond dissociation energy is 156 kilojoules. All right. So first is सबसे ज्यादा chlorine because of repulsions, electron repulsions. Then comes fluorine, then comes bromine, then comes fluorine, then comes iodine. So they said fluorine bond dissociation energy is less. Yes, it is because the small size is small. The size is small. Yes, the bond dissociation energy. The reason is right. Why? What is the reason, students? Yes, fluorine bond dissociation energy is less. Is less. Why? Because of lone pair repulsions. Because of this lone pair repulsions, when they come close together, automatically the repulsions will be there and I can apply less energy compared to others. So they said assertion was wrong what they give, but correct assertion is this. Reason is right. Clear, students? Okay. So the supporting statement, assertion fluorine has low reactivity. No, fluorine has high reactivity. This is one. And fluorine bond energy is low. Yes, it is right because of lone pair repulsions. Right, students? Easy. All right. Next question. Let's see. Next question is fluorine bond is strong. Fluorine is small in size. Yes, when I talk about this, yes, check carefully. Fluorine bond is strong, they said. Okay, observe. A is false. Assertion is false. Fluorine is small in size. This is right. So A is false. Reason is true. Let us reason it. Why FF bond in molecule is strong? Why it is strong? Just say. They said assertion is basically wrong. Why? Fluorine, when I have to compare, yes, students, just check here the bond length. Yes, FF bond is weaker than CCl bond. Why, students? What is the reason? Because here the bond length is shorter. Bond length is shorter. Though the bond length is shorter, compare how much it is. 1.33. It is close, accepted. Here the bond length is 1.81 angstroms. This is, but here what is happening, students? Because of this repulsions, yes, because of lone pair repulsions, the bond has become weak. Bond has become weak. Bond is weak. But what did they give me? What did they give me? They said bond is strong. They said bond is strong. This is wrong. Here, the actual reason is because of lone pair repulsions. bond is weak. This is the correct statement. Correct. So reason is right. Fluorine is small in size. See here, compared to everything from top to bottom, fluorine is small in size. So the reason is right. Clear? Next statement. HNO3 oxidizes sulfur to sulfuric acid and selenium oxidized to selenous acid. Whether it is right or wrong. Okay. The presence of 10 electrons in the 3D subshell causes pore shielding and finally attracts the outermost electron more strongly for selenium. So basically, students, both are right statements. And reason also is talking about this. Let's see it. Yes. Nitric acid oxidizes sulfur to sulfuric acid. See these reactions? Yes. Nitric acid, being an oxidizing agent, it converts, right? It oxidizes sulfur to sulfuric acid. So assertion is right. Nitric acid, being an oxidizing agent, gets converts selenium to this acid. See here. 0, it is going from 0 to, if I calculate this, 4 2s are 8 plus 2. So this is plus 6. Correct? 0 to plus 6. Here in this case, 0 to plus 4. Yes. So is it not oxidation? Yes, loss of electrons. So oxidation, oxidation. That's the reason assertion is right. Now, if I see this, they have given me one question. The presence of 10 electrons in the 3D subshell causes pore shielding and finally attracts the outermost shell. Yes. If you see, there are 10 electrons in the outermost shell. See here, 3D10. 3D10. Because of this 3D10, 3D10 electrons, d orbital has less shielding or ineffective shielding. Correct? Yes, students. So because of this pore shielding effect, what happens? The outer electrons are, whatever electrons are there, are more strongly pulled by the nucleus. Correct? So that's the reason. That's the reason I said both the reason as well as the assertion both are related to each other. That's because it is pulling the electrons inside, so what will happen? It is not, basically the loss is going on in that. Okay. Next thing, oxygen has a less electron gain enthalpy than sulfur. Oxygen is more electronegative than sulfur. Let's see the students. Basically, oxygen has less negative electron gain enthalpy than sulfur. Yes, it's right. Oxygen is more electronegative than sulfur. It's right. But this is talking about electronegativity and this is talking about electron gain enthalpy. That's why both assertion and reasoning are correct, but reason is not the correct explanation of assertion. Shall we see the explanation? Yes. Let's see the first one. Oxygen has less electron gain enthalpy than sulfur. Why? What is the reason? See here, students. Reason. First of all, oxygen has small size. Okay, compact, the nature is very very compact, so whenever the incoming electron enters, you can't accommodate because electron gain enthalpy means what? Oxygen being 1 is 2, 2 is 2, to p, to p4, so 4 electrons are there. This 4 electrons, 1 2 3 4 5 6, or 4 rather, first let us write 4. So these 4 electrons whatever are there in the outermost shell, what will it do, students? When an electron enters into the shell, it will cause repulsion. This electron and this electron will cause repulsion. So because of this electron repulsions, the electron gain enthalpy will be less negative. Less electron gain enthalpy would be there. Yes, right. Then they have given one more thing. They said oxygen is more electronegative than sulfur. Yes, the reason is right. This is also right. Assertion also right. Reason also, see here. Electronegativity, oxygen is more. Yes, oxygen is more. Right. Reason also right. But this is talking about electronegativity. This is talking about electron gain enthalpy. Both are different concepts. That's why assertion is, reason is not supporting assertion. Next concept. Sulfur, oh, 1 second, students. 1 second. Right. Next, sulfur has a, sorry, let me maximize. Right. Sulfur has a greater tendency for catenation. All right. Then oxygen. Oxygen bond is weaker than sulfur bond. Yes, students. Remember, sulfur has greater tendency. Yes. Oxygen bond is weaker than sulfur. Yes. Both are talking. See, catenation is nothing but self-linking. Correct. Now here the bond is weaker. That's why it is when the bond is weaker, what happens automatically? It uh, tries to link. How? Let us explain it. Here assertion is right, reason is right. Let's see. Sulfur, when I take, see here, it forms so many types of self-linking compounds. This is the catenation property. Why? Why? Because when I see here, sulfur bond length is 189 picometer. Okay. Oxygen bond length is 147 picometer. Right. Yes. They have given me assertion. Yes. Sulfur links. Then they said oxygen bond is weaker, they said. Yes. Oxygen bond length is less. Bond length is less. Because the bond length is less, automatically what happens, students? What happens? The bond length is less means bond is weaker. Bond is weaker. That's the reason. That's the reason. Assertion right. Reason also right. Because oxygen bond length is only 147 picometer. This is 189 picometer. Right? Perfect. Now, next question, students. Let's see. Water is a liquid while H2S is a gas. All right. So, is it right? Is it right? Yes. Yes. Water is a liquid. H2S is a gas. We are going to prove that. Reason, there is a strong intermolecular hydrogen bonding in H2S. All right. Yes, students. First of all, hydrogen sulfide, there is no hydrogen bonding. That's why reason is incorrect. Which option should I go? This one. Let's see. Water is a liquid while H2S is a gas. See here, students. Yes. In water is a liquid because of which bond? Hydrogen bonding. Correct? Because of hydrogen bonding, it is a liquid. Yes, that's the reason. In H2S, there is no hydrogen bonding. No hydrogen. Normally, hydrogen bonding means what, students? It is bond. Bond means chlorine, hydrogen, oxygen, hydrogen, nitrogen, hydrogen. Correct? So that's the reason. Now check the assertion part, whatever they have given, it is right. Now, there is a strong intermolecular hydrogen bonding in H2S. There is no hydrogen bonding. That's why reason is wrong. Clear? Next question. Both the SO bond and sulfur dioxide are equal. Sulfur dioxide molecule exhibits resonance. All right. Yes, both are equal. We are going to prove it. Sulfur dioxide molecule exhibits resonance. Yes, it is right. Let us see. Both are talking about the same concept. So assertion right, reason right. Assertion is the correct explanation of reason. Let's see. Sulfur dioxide in SO bond in sulfur dioxide are equal. See, yes. Here there are two bonds, one dative bond. Here one with this one and two bonds. So both the bonds, the SO bonds are in sulfur dioxide are equal. That's the reason assertion is right. Now, reason is talking about, it says it exhibits resonance. Yes, students, see here the shift of the pi bond here. Yes. So SO bonds, they exhibit SO bonds show resonance. SO shows resonance. Sulfur dioxide shows resonance. Yes, that's why reason also. Easy? Okay. Next question, students. Ozone is a powerful oxidizing agent. Okay. Ozone decomposes to oxygen. Yes. Ozone is a correct thing. It is an oxidizing agent. Ozone decomposes to this. Yes. But this is talking about oxidizing property. This is talking about release of oxygen. Both are different, no? Different. If it talks about nascent oxygen, right, but it is talking about different property, that it is releasing oxygen. So assertion is right, reason is right, but reason is not the correct explanation of assertion. Let's see this, how ozone is powerful oxidizing agent. See here. When they gave assertion, yes, it is right, because ozone on decomposition, it releases nascent oxygen. This nascent oxygen is helpful in creating or causing oxidizing properties. Oxidizing properties. Correct, my students? Yes. So assertion right. Reason, they said it decomposes into oxygen. Yes, this is also right. But both are different concepts. Done. Next question. SF6 is very inert molecule. Reason, it is difficult to break SF bonds. Wow, that's nice. SF6 is an inert molecule. Yes, it is right. We are going to explain now. It is difficult to break SF bond. Hmm. It is difficult to break SF bond, they said. So this particular thing is incorrect. Why? Why? Let's see. So SF6 is a very inert molecule, they said. Now check this, students. Check this. Here in SF6, problem is it is sterically hindered. Sterically hindered means what? Sulfur atom is surrounded by six. Sulfur is surrounded by six fluorine atoms. How many atoms? Six fluorine atoms. So because of the six fluorine atoms, it has become bulky. Sterically hindered means bulky. Bulky. So whichever molecule, when water tries to enter here, it is SF6 plus water, there is no reaction. There is no reaction because it is does not allow, because of this bulkier group, it will not allow to react. So is it not inert? Yes. This SF6, because of the bulkiness, it is inert. So assertion is right. They said assertion, it is inert. Then reason, they gave me something else. It is difficult to break SF bond, they said. Now, understand, students, in the reason case, first of all, this SF bond are forming strong covalent. This is a covalent bond. Covalent bond, right? Right. This is, everything is a covalent bond. So covalent bond requires what? High energies. They require high energies. So when they require high energies, it's very difficult to break the bond. Correct? Right? Very difficult to break the bond because of the covalent. Right. Now they said when I start breaking, when I am supplying energy, activation energy, and I'm trying to add this one, so it requires a lot of energy for breaking it. Accepted, right? But here, what did they give me? It's difficult to break SF bond here, they said, but observe carefully, students. I understand it is a covalent bond. Yes, it is difficult. It is difficult to break. Yes, but here, important thing is when it is undergoing hydrolysis, when it is undergoing hydrolysis, e- extremely fluorine will not allow it to enter, right? Obviously, because of this polar bond, it will not undergo any reaction. But here, problem is assertion is talking clearly, but reason is different concept. It is not talking about the reactivity. Yes, it's talking about a covalent bond which is strong. It is strong, I can't break it, obviously, but both are different concepts. Okay, right. So that's the reason, students. That's the reason. If I have to clearly say, assertion is right, reason is correct, both if I can say. But problem here, it is not supporting. That's the reason I'm taking C. Next question. H2Se is more acidic than H2Te. All right. Yes. Assertion H2Se is more acidic than H2Te. It is wrong. Bond dissociation enthalpy decreases with increased size of an atom. Okay. Let's see. Bond BDE decreases as size increases. Ah, this is right. Let us see. H2Se is more acidic than H2Te, they said. Now, first of all, see the students. Acidic nature means what? Acidic nature means ability to donate a proton. Donate a proton. Ability to donate H plus ions. Correct. Now observe carefully. In case of H2Se, the bond dissociation energy is 276 kilojoules per mole. In case of H2Te, the bond dissociation energy is 238 kilojoules per mole. Now you only tell me which can release the proton easily. H2Se can release or H2Te, which is whose energy is less? This one. Correct? This energy is less. Energy BDE is less means I can easily release proton. Easily release H plus ions. So according to this, H2Te is more acidic. Right? What did they give me? They gave me H2Se is more acidic. They said that's wrong, no students. Here it is 276 kilojoules. Difficult to break. More energy. Here less energy. 238 kilojoules per mole. I can easily break it and send off this proton out. So this is a wrong statement. What is the correct statement? H2Te is more acidic than H2Se. Okay. So second thing, bond energy decreases with increased size of an atom. Yes, you see, from top to bottom, when I see the size is increasing. Correct? Top to bottom, what is increasing, students? Size is increasing. When size increases, what happens? What happens? Bond dissociation energy decreases. Easy, easy. Yes, right. So that is what we said. That's why reason is right. Assertion is wrong. Assertion is wrong. Clear? All right. Next question, students. Sulphuric acid is highly corrosive. Sulphuric acid is a powerful oxidizing agent. Yes, it is right. Both are right. But here it is talking about corrosive nature, getting corroded. This is talking about oxidizing nature, right? Both are right, but reason is not the correct explanation. Let's see this. Why assertion is right? Observe carefully, students. Sulfuric acid, because what happens? It's going to convert into sulfurous acid and release nascent oxygen. This oxygen, because of this nascent oxygen, it starts or it acts rather as a powerful oxidizing agent. Powerful oxidizing agent. But here, what is corrosion? Corrosion is eating up of the metal. Eating up of the metal. Correct? Because of what? Because of moisture, because of air, because of moisture. That is corrosion. Eating up of the metal. Correct? So this is a different concept. This is a different concept. Correct? That's the reason both are correct. This is also correct. Assertion also right. Reason also right. But both are not related. Okay. Next question. Sulfur dioxide is a good bleaching agent. Sulfur dioxide readily oxidizes to sulphate in the solution. Yes, this is also right. This is also right. Both are interrelated topics. Let's see what it is. Sulfur dioxide is a good bleaching agent. Why? See here, students. When you dissolve sulfur dioxide in water, it's going to form sulfurous acid. That sulfurous acid further dissociates into a proton and sulfite ion. Okay. Now, this sulfite ion, right? Observe carefully, students. Whatever is there, the dye, whatever you're taking, it combines with that and forms sulfate. Now, because of this nascent oxygen, whatever was released, because of that, it is acting as a bleaching agent. Okay, right? That bleaching agent, colored will become colorless. Now, see, students, they have given sulfur dioxide is a good bleaching agent. Yes, it is right. Colored to colorless, assertion is right. They have also given it oxidizes, sulfur dioxide readily oxidizes oxidizes to sulphate. Yes. Sulfur dioxide is oxidizing into sulphate. Yes. Assertion, reason also right. Yeah. All right. So assertion right, reason right. Next thing. Xenon forms fluorides because 5d orbitals are available for valence shell. Yes. According to this, yes, it's right because xenon has 5d orbitals for expansion. This is also right. Let's see. Let's see. Both are talking about the same. See here. Xenon forms more fluorides. See here. Compared to everything, xenon forms more number of fluorides. So assertion is right. Then they said because 5d orbitals are available for valence shell expansion. Correct, students, here in xenon 5d orbitals. So if I take xenon, what happens? Available for valence shell expansion. Yes, from this the next shell which is available is 5d, so comfortably it can expand its configuration 1 2 3 4 5. That's why it is able to form more. Yes, so 5d expansion is there. That's why reason also right. Both are talking about same oxidation states. Next, Ka1 for sulfuric acid is very high than Ka2. Sulfuric acid is dibasic, which forms two series of salts. Yes. First of all, Ka1 is more than high for sulfuric acid. Yes. It is the assertion is right. We are going to prove that. It is a dibasic acid and forms two types of salts. It is right. Let's see the students. See here. So basically, when sulfuric acid dissociates, it breaks up into H plus plus HSO4 ion. The acid dissociation constant for this is more than 10. This HSO4 minus ion further breaks up into H plus and SO4 minus 2. Here the acid dissociation constant is almost 1.2 into 10 raised power of minus 2. So observe carefully. Ka1 is very much greater than Ka2. Why, students? Here you are taking out a proton from a neutral molecule. Correct? You're going to take it from a neutral molecule. But here what is happening? You're going to take out this H plus from an ion, which is difficult. This is difficult. Correct? So whatever they have given, Ka1 greater than Ka2, assertion is right. Let us see the reason, students. It forms two types of salts. They said it is dibasic. Yes. When I take sulfuric acid, it is, observe carefully, this is dibasic in nature. Reason also right. And it forms two types of salt. Yes, students, it forms. How? Just check. Sulfuric acid will react with sodium hydroxide and forms NaHSO4 salt, bisulfate salt. Same sulfuric acid reacts with sodium hydroxide and forms Na2SO4 salt, sodium sulfate. So both the salts it forms. So that's the reason two different types of salts. Reason also is right. Clear, students? Okay. Halogens have characteristic color. Halogens readily accept electrons from halide ions. Yes, this is right. This is also right. But problem here, this is talking about color. This is talking about acceptance of electrons. That's why assertion right, reason right, but as reason is not the correct explanation. Let's see. Halogens are colored. Here. Halogens, because they absorb energy from the visible light, they have different colors. So, because of this excitation of outer electrons and absorption of light, they have different colors. Assertion is perfectly right. Fluorine color, L, chlorine, bromine, iodine. Then they said halogens readily accept electrons. Reason also right. See, they accept the electrons and form halide ions. These are all halide ions. Fluoride ion, chloride, bromide ion. Both are right. But this is talking about color property. This is talking about halide. Both are different concepts. Clear? All right. Next question. Fluorine shows positive oxidation state and fluorine has exceptionally small size. All right. Fluorine shows positive oxidation state. Shows only positive oxidation state. Yes, is it right? Is it right? Fluorine only shows positive oxidation state. Hmm. Let's check. Fluorine size is exceptionally, fluorine has exceptionally small size. Let's check, students. Right. First of all, fluorine shows only positive oxidation state. This is wrong. Correct? It can never show it. Fluorine has exceptionally small size. Right. So, what is this? Assertion is wrong. Reason is correct. Let's see. First of all, when I speak, fluorine is the most electronegative atom. Most electronegative. So what will it do? It will always try to take one electron. Because of this electron, what will happen, students? It can only show -1 oxidation state. Yes. So that's why assertion what they've given is wrong. Only it can show -1 negative oxidation state only. When I come to reason, they have given fluorine as exceptionally small size. Yes. See, students, here basically 0.64 compared to everything, size is small. Small size. This is ion size also. When you compare with everything, small size. Clear? That's why the reason is right. Small size. Done. Okay. Sure. Next, let us go to the next question. Chlorine water is more permanent bleaching than sulfur dioxide. Okay, right. Yes, it's a permanent bleaching because it releases nascent oxygen. See here, suppose if I have a page. Okay, I have a page, I'll show you. So chlorine water oxidizes while sulfur dioxide reduces. Perfect. This is also right. So reason, it's talking about bleaching agent because of nascent oxygen. It's talking about oxidizing and reducing. Yes, both are right. Let's see. Chlorine is a more permanent bleaching agent. See this. Yes. When chlorine reacts with water, it's going to release two types of acids: hydrochloric acid, hypochlorous acid. So this hypochlorous acid further releases nascent oxygen. Because of this nascent oxygen, it acts as a bleaching agent. Bleaching agent. This is bleaching agent. And it also, if I have to talk you, it's a permanent bleach. It's a permanent bleach, students. Permanent bleach. Okay. Now, sulfur dioxide, they said, chlorine water oxidizes. Yes, it oxidizes because of oxygen release. Yes, assertion right. Chlorine water oxidizes and oh, it's a bleaching agent, right? In the reason, chlorine oxidizes, yes, and sulfur dioxide reduces. This is your reducing property. So, chlorine oxidizes, perfect, and so too acts as a reducing agent, reduces. Clear? So, assertion right, reason right. Next question. Fluorine forms only one oxo acid HOF. So, fluorine does not have d orbitals in the valence shell. Yes, it's right and it's right. Let's see. Let's see, students. Fluorine is basically having only -1 oxidation state. So it will form only one type of oxo acid, that is HOF. And they said it does not have d orbitals. Yes. See here, first assertion is right. It has only -1 oxidation state. That's why it forms only one oxo acid. Fluorine doesn't have d orbitals. Yes, reason also is right. It has no d orbitals. No d. It can't expand also because of small size. That's the reason. Assertion, reasoning, both right. Next question. Noble gases have very low boiling point. Right. So if I have say yes, assertion right. Noble gases have fulfilled valence configuration. This is also right. But remember, students, noble gases have, this is talking about valential configuration. This is talking about boiling point. Both are different concepts, but both are correct. Let's see. Noble gases have low boiling point. Check here. See here. Compared to all, they have very low boiling point. It is in minuses. It's in minus. Why? Because low BP is due to inert gas configuration or stable configuration. Correct, students? Okay. That's why assertion is right. Then they said noble gases have fulfilled configurations. Yes. Duplet, octet, 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 octet. So reason also is right because they have duplet configuration and octet configuration. But both are different concepts, no students, both are different. That's why I selected option B. Next question. Among the noble gases, only xenon forms large number of compounds and xenon ionization enthalpy is similar to that of oxygen. Among noble gases, yes, right. Assertion is right. But ionization enthalpy, which is similar to that of oxygen. If I have to tell you students, almost it's near actually. If I have to say 1166, 1170, it is almost similar. It's almost, which is similar, no? It's almost similar. Let's see that. Let's check that. So basically here, assertion is correct. Reason also is correct. Assertion correct, reason also correct. But explanation, it is not giving the similar explanation. Let's see here. Xenon forms different types of compounds. Different types of compounds. So among all the noble gases, xenon forms the maximum compounds. Next, reason. Oxygen and xenon have ionization enthalpy similar. See here. Xenon ionization enthalpy is so much, and as oxygen's ionization enthalpy is so much, xenon also so much. Almost similar. So reason also is right. Clear? Okay, next question. Sulphuric acid can be used to prepare hydrohalic acid from the salts. Sulphuric acid is less volatile than hydrochloric acid. Okay, now understand. Sulphuric acid can be used to prepare hydrohalic acid from the salts. Yes, it is right. We're going to see the reaction. Sulphuric acid is less volatile than hydrochloric acid. Yes, this is wrong. We will see why. Reason is checked. I said first sulphuric acid can be used to prepare hydrochloric acid from salts. Let's see. First of all, can be used to prepare, can be used. Okay, I'm taking NaCl. I'm adding sulfuric acid to this. So what will happen? Whenever it is there like this, break it like this. Okay, check. NaHSO4 HCl. So what am I getting? I'm getting NaHSO4 plus HCl. Right? Okay. Then simple. One more. Let us see. NaNO3 plus H plus HSO4 minus. This is plus, this is negative. NaHSO4 plus HNO3. NaHSO4 plus HNO3. Now see students, what did they give me? What did they give me? Assertion. Read this. Sulfuric acid can be used to prepare hydrohalic acid from chloride salts. Yes, I can prepare hydrohalic acids from chloride salts. Assertion is right. Sulfuric acid is less volatile than hydrochloric acid. Right. Remember, students, sulfuric acid has a boiling point of 337 degrees centigrade. So it's considered non-volatile. Non-volatile. Yes, but when I take HCl gas, when I take nitric acid, they are less boiling point. Less boiling point. I can easily take them for double decomposition reactions. I can use it for double decomposition reactions. So what did they give me? Sulfuric acid is less volatile than, no, the boiling point is more. So sulfuric acid is not volatile. It is not volatile, right? Sulfuric acid is not volatile. Its high boiling point is low, very high. So, but they've given me, they are talking about Sulfuric acid less volatile than hydrochloric acid, and the reason what they have given is not. So basically, this is also right. If I have to talk, sulfuric acid is less volatile because the boiling point is high, because the BP is 337 degrees centigrade. The BP is high. Right, accepted. It's right. If I have to take correctly, um, this is used to prepare. I think students should not go with wrong, because sulfuric acid is less volatile because the boiling point is more. So if the boiling point is more, sulfuric acid is less volatile. Okay, one second, students. One second. If the boiling point is more, means it will take less time to vaporize. Correct? It will take less time to vaporize. So less time to vaporize. Okay. So the option, if I have to talk, yes, it is less volatile. It's right. Next thing, students. Let's okay. Okay, this is already done. This is done already. Please check it. Sorry, this is done. Please check it. Next question. I have explained this already. Check this. Next, HClO is a stronger acid than HBRO. Right. So first of all, it's right. Next, greater the electronegativity of halogen, greater will be the attraction of electron pairs towards it. Hence, more easily H plus will be released. All right. HClO is a greater, stronger acid than HBr, right? The reason, greater the electronegativity, greater the attraction towards electron pair, hence more easily it will be released. Obviously, this is also perfectly right. Both are explaining. So now see the reasons, please. See here. Chlorine is more electronegative than bromine, correct? Than bromine, right? Now, chlorine size is small size. So it will withdraw electrons. From where chlorine, oxygen, and hydrogen bond, it will withdraw the electrons. Correct. Now here size is large. So electronegativity is less. So more electronegative. I have written already up here, less electronegative. Correct. What will happen? So the tendency to withdraw the electrons, bromine OH is less. Na? It's less because electronegativity is less. That's why. That's why assertion is right. Reason also right. Clear. Next question. Reactions of sulfur dioxide and H2S in the presence of Fe2O3 catalyst gives elemental sulfur. All right. In this, H2S is acting as a reducing agent. Let's say this, students. Reaction of sulfur dioxide with H2S in the presence of a catalyst gives elemental sulfur, whether it is right or wrong. If I have to say, yes, it is right. In this reaction, H2S is acting as a reducing agent. This is also right. But this is talking about a reaction. This is talking about a property. So, assertion reasoning right, but reason is not the correct explanation. Let's see. See this. This. Sulfur dioxide is a reaction of sulfur dioxide to H2S. Remember, it's giving me elemental sulfur. Yes, the assertion is right. Reason, here H2S is acting as a reducing agent. See here. From -2 oxidation state, it is going to 0. -2 to 0. All right. What is happening, students? It is oxidizing here, oxidation, this one, but it is acting as a reducing agent. Yes. Reason also right, but both are different concepts. Correct? So like that. Wow. We have completed complete P block, assertion and reasoning are complete. Assertion P block, assertion and reasoning completed. One small help I need from you all students. One small help. Ask your friends to subscribe to the channel. We are going to reach 100K. I want all your support. Subscribe to the channel, please, and share the video. Share the video. Share the video as much as you can. So I am giving you quality education. So WOC will meet you again on Sunday at 8 p.m. Sunday 8 p.m. with MCQs, P block MCQs. Okay. So all the best students. Bye bye. Thank you so much. Please share the video. Thank you.